Hello students, welcome to Go Vidya. So in the series of 1000 questions for the TRANSCO and GENCO. So we have started already control systems. Now let us see the continuation of this control systems problems. If you see the question, what they asked for the signal flow graph diagram is shown in the given figure, the transmittance between x2 and x1. So that means they are asking like transfer function between x2 and x1. Yes. So obviously, how many forward paths are there? We have to identify. So I can say from x1 to x2, this one forward path. And here also you see x1 to like this, another forward path. Therefore, two forward paths are there. So here, number of forward paths are equals to 2. So as per Mason's gain formula, we know that, but before that, let us identify what are all the forward paths, what are all the loops, what are all the non-touching loops. We have to identify. So how many loops are there? Okay, let me write what are all these first forward paths. So let us say forward path F1 is equals to what? RSU, the gain of the first forward path. RSU. What is the second forward path? EFH. EFH. Those are the two forward paths. And now number of loops. Which loops? Number of individual loops. How many number of individual loops are there? This is one individual loop. This is another individual loop. There are two individual loops. Two individual loops are there. What are all those two individual loops? Whose gain is, let us say, L1 is equals to how much? S into T. And what is L2? F into G. Can I say that? Yeah. So similarly, number of two non-touching loops. Number of two non-touching loops. Number of two non-touching loops, which are nothing but pair of two non-touching loops. How many are there? Only one. See, this is one loop and this is another loop. Both are not touching, right? So what is its gain? L12 is equals to how much? ST into FG. ST into FG. Okay, na? Now what is the Mason's gain formula? Transfer function. Transfer function is equal to M1, or you can say here I have used F1, you will write it like F1. F1 delta 1 plus F2 delta 2 whole divided by delta. This is what the Mason's gain formula. What is actually F1? RSU. What is F1? RSU. What is delta 1? That is the question here. Delta 1 is nothing but the value of delta which is not involved in the first forward path loops. So tell me how many loops are there? Two loops in the first forward path. This ST loop is involved in it. So which loop is not touching this forward path? This is the one, right? So we have to find out the delta 1 for this. So what is that? 1 minus this is, sorry, not S, 1 minus FG, correct, plus what is F2? Forward path, EFH, which is written. So E, F and H. And what about this? How much is value? 1 minus ST, because this is the loop is not touching with respect to this forward path. So can I write like 1 minus ST? 1 minus ST whole divided by, so F1 delta 1, F2 delta 2 is over. Now what else left? 1 minus, how many individual loop gains are there? There are two loop gains. 1 minus ST minus FG plus what? Two non-touching loops, ST into FG, right? ST into FG. Okay. If you see in all the options, RSU, EFH. See, RSU, EFH. In every case, it is there. RSU. So here we have RST. So there is no possibility of RST. So therefore, this option is wrong. RSU, EFH, both are possible. You see, you take the LCM of it. RSU into 1 minus FG. RSU into 1 minus FG. So can I say that this is the only straight away answer? You take LCM, RSC into 1 minus FG, EFH into 1 minus ST, EFH into 1 minus ST, and denominator you take the product of it. Okay. So therefore, the final answer is this. Whenever if any two non-touching loops are coming into the picture, you have to be care must. The reason is, if you forgot to calculate, even if you are able to calculate the delta, but delta 1 and delta 2 is most important. Why delta 1 and delta 2 most important? Because in this particular forward path, the delta 1 value is nothing but the loop which is not touching this forward path, which is the one, this one only. Similarly for this, this is not the touching one. Okay? So this is how we are going to solve. Finally, the answer is option A. So here we have, like, directly we have written, but the examiner has given like it is a fraction manner. So if you rearrange it, you will get the same answer. Okay. Now let us see another question. Now, if you see the question, what is that? Consider the signal flow graph shown in the figure. Calculate the gain x5 divided by x1. x5 divided by x1, which is nothing but what? They have given x5 here, but actually this and this both are same. This is x5. Okay. So as usual, x5 by x1 from the Mason's gain formula. From the Mason's gain formula, yes. What is the transfer function definition here as per the question? x5 by x1, which is equals to what? Yes. How many forward paths are there? Very simple. Only one forward path is there, because these three are loops. So number of forward paths are how many? Only one forward path. So obviously delta 1 is obviously 1, right? So what is that? Gain of the forward path A, B, C and D. A, B, C and D. That's it. Nothing is there. Now number of individual loop gains plus number of two non-touching loop gains and so on. Minus, plus, minus and so on. But if you observe very carefully in this, this is one loop. Okay. This is also another loop. And this is also another loop. Hai? But strictly speaking, three individual loop gains we can calculate. What is that? BE, CF, DG. BE plus CF plus DG. We have written. But two non-touching loops here is the major thing. How many two non-touching loops are there? If you observe, this is the loop 1 and this is loop 2 and this is loop 3. There is no other loops, right? So can I say loop 1 and loop 3 are not at all connected together? Can we say that? Loop 1 and loop 3 are not at all connected together. But L2 is common for this and this. So therefore, we have only one non-touching loop, one pair of non-touching loop, that is this one, L1 and L3. Whose gain is how much? BE, this and multiplied with DG. BE multiplied with DG. So here you write, I am writing with red color, BE with DG. Now could you please check which answer is very close to this? BE plus CF plus DG plus BE DG. Therefore, this is the answer. Correct. The only thing, one forward path, straight away numerator, no problem. Here you see ABCD, here it is there. Fortunately, very lucky. The thing is, no numerator is having ABCD apart from this. So without like using this information also, we can directly mark it as option C is correct without doing this much analysis. But anyhow, this loop and non-touching loops information is important for us for solving the numerical. So that's why I've solved this. You see, any one of the option, is it matched with the C? No. Numerator, you see A, B, C, D, B, E, D, G, this. Okay. That's how we have to solve. Okay. Now let us see another question. Now this question refers what? They have given the block diagram and they're asking transfer function of it. So the most important thing when we are having a block diagram, if suppose simple block diagram, that is fine. Suppose some complex block diagrams are come into the picture, then it's difficult to find out because takeoff point, summing point, like that we have to do. But if you know the conversion from block diagram to signal flow graph and then transfer function, it would be very easy. So let us try to incorporate that concept like block diagram to SFG and SFG to this. Can we do that? So let us see. So can I say this block diagram having how many forward paths? Can I say this is the one forward path, right? Where is the another forward path? This is the another forward path. And do we have any other forward paths? No, right? So therefore can I say only two forward paths? So forward path F1 is equals to, it is what? G3. Only G3. What is the second forward path? G1, G2. Only two forward paths are there. G1, G2. How many loops are there? If you see very carefully, this is G1, H1 is one loop. G1, G2, H2 is one loop. One more loop is also hidden in this. What is that? You see here. G3 and H2 is also another loop. Okay, therefore how many loops? Three loops are there. Loop 1 is equals to how much? I'm just taking from inside to outside I'm going. So one loop gain is minus G1 H1. Another loop gain is, obviously in front minus is there, G1, G2 and H2. Another loop gain is L3 is equals to minus G3 and H2. Obviously, you know why I'm putting this minus, because it is a negative feedback system. Now, obviously, from Mason's gain formula, what is the transfer function? C of S by R of S. What is the numerator? G3 plus G1, G2 I can write directly. Why so? Two forward paths, M1, delta 1 we have to calculate. So if you observe carefully, this is the path which we have, okay, but in this path, this loop is also included. This loop is touching, and this loop is also touching, and this loop is also touching. So therefore, there is no loop which is missing from this forward path. So all the loops are included in it. So therefore, delta 1 is 1. Now when it comes to delta 2, you see here, this is the only path which is common to all the three loops. Therefore, can I say all these loops are also included in this forward path? Yes. So therefore, we can say from this, the delta 1 and delta 2 value is obviously 1. So which option is suitable? Either it could be A or either it could be C. Okay. So anyone can be possible. So now how many loops are there? Three loops. 1 minus of how many individual loop gains? Minus G1 H1 minus G3 H2 minus G1 G2 H2. Is there any loops, any two loops are touching, or any two loops are non-touching? See, you see here, this is the loop now, and this is one loop now, and this is one loop now. All three loops are connected to this thing. Correct na? So therefore I can say that there is no possibility for two non-touching loops and obviously three non-touching loops. So there is no concept of it. So they can directly write like G1, G2 plus G3 whole divided by 1 plus G1 H1 plus G1 G2 H2 plus G3 H2. So which option is correct? So option G1 H1, G3 H2, G1 G2. So this is the option correct and this is the wrong. But generally there is a possibility of committing a mistake. What is the possibility? That see G1 H1 G2 H G1 G2 H2. So what? G1 H1, this is one loop. G1 G2 H2 is another loop. There is a possibility, but we forgot that this is also another loop. Got it now? So generally what we mistake, this we will forgot. That's why you will be getting as an option A. Care must be taken when you are solving any question. If you are getting answer as in option A, it's my suggestion that if you are getting option A, do it one more time, so that it is easy for you to recheck. Any other option, no problem, but when it is an option A, you just do one more time. Okay, so this is the transfer function of the given block diagram. Now let us see one more question. So now in this question, what they're asking, find the transfer function of the given signal flow graph. So what is that? C of S by R of S is equals to how much? C of S by R of S is equals to how much? So first you need to identify how many forward paths are there. The good thing about this question is we have only one forward path. So what is the first forward path? Or only one and only forward path is what? G1, G2, G3. This is the only forward path. G1, G2, G3, G4. But is there any forward path? No. Now tell me, only one forward path is there. What is the obvious value of delta? Obvious value of delta 1 is 1. Delta 1 value will be 1. And now what about the loops? How many loops are there? Loop 1. Loop 1 is equal to the small loop. You see here, the small loop whose gain is -1. L2. Which loop? This big loop. This one. Are you able to see? This one. What is that value? G1, G2, G3. G1, G2, G3 into -1, which is nothing but minus G1, minus G2, G3, G4. What about loop 3? What about loop 3? G3, G4 -1. Correct na? It means like I could say this thing. Oh, it is gone. Okay. Minus G3, G4. Minus G3, G4. Where is another loop? Minus G4. Minus G4. I hope it is clear. 1, 2, 3 and 4. Total 4 loops are there. How many 2 non-touching loops are there? 2 non-touching loops are how many? How many pairs are there? You see, this loop is not in touch with this loop. See, red to red color. And this loop is not in touch with this another loop. So this is, let us say L1, let us say L2, let us say L3. See, I can say L1, L2, L1, L3. Correct na? Okay, let me give a naming like this. I think so I have given in the same way. Okay, it would be like, let me give the same numbering so that it will be very easy. What is this small loop? L4. What is this loop? Minus G3, G4, which is nothing but L3. So you see L1, L4 and L1, L3. What is that? L1, 4. How much this L1, 4? L1, 4 ka gain product, how much? So minus G4 into -1. -1 into minus G4. Minus G4, which is nothing but what? G4. Another one, L1, 3. How much this value? L1 into L3. So minus 1 into minus G3, G4. इसका total value G3, G4. G3, G4. So now what about this transfer function? Okay. So tell me what is the numerator? G1, G2, G3, G4, G1, G2, G3, G4, G1, G2, G3, G4. All are there. So numerator wise, there is no possibility of cancellation or removing anything. So numerator is G1, G2, G3, G4 as per Mason's gain formula, transfer function. Now what about the denominator? 1. Anyway, individual loop gains are all negative, so you can put plus straight away. What else left? This is 1 plus, so this is 1. And what else left? G2, G3, G4. G2, G3, G4 plus G3, G4 plus G4 till this is over. Now what about two non-touching loops which are plus? What are these? G4 plus G3, G4. Correct, na? G3, G4. Now you see here this value is going to be 2 and this is 1 Z4 and this is another Z4 which is nothing but 2 Z4. So 2 everywhere is there, so this is the wrong answer. Now 2 Z4 everywhere it is there, again it is quite challenging then in that case. So G3, G4. So G3, G4, 2 G4, 2 G4, 2, 2, G3, G4, G3, G4. So there is a possibility of either this or D, B or D. Okay, na? So let me take up this. So how many are there? 2 G3, G4 is there. 2 G3, G4 is there. Okay, na? If you observe carefully, 2 G3, G4, 2 G4, G2, G3, G4 and 2. I hope it is matched. But in these two cases, it is not matched. So therefore, this is going to be correct and these two are wrong. Okay, na? We just compare. G3, G4s are 2 and 1 G2, G3, G4. 1 G2, G3, G4. Okay. I hope it is clear, this question. Okay? Now let us move on to the next question. So as per this given question, it is open loop transfer function. It is open loop transfer function. Generally, the type of the system is defined for open loop system. Generally, type we are going to talk about with respect to open loop type. But order you can talk about in terms of either open loop or closed loop. No problem. Both are same. Either open loop or closed loop, both are same. But type of this system is with respect to only open loop system. Okay. Now if you see, the open loop system is sufficient to say whether the type and order of the system is how much. So can I say the G of S? Can I say the G of S is like this 1 upon, I am simplifying, S square plus S, or as per the given question you can write like this. Here both I want to show you, that's it. Yeah. So how to define the type of the system? The type of the system can be defined as the number of poles at origin in an open loop system. Number of poles at origin in an open loop system. How many poles at origin we have here? Poles at origin means this one. This is the S to the power of 1, which indicates, this indicates the type of the system. This indicates the type of the system. And the highest degree in the denominator, the highest degree of the polynomial in the denominator of a transfer function will be called it as order of the system. Therefore, tell me what is the type of the system? Can I say type of the system is equals to 1? Order of the system is equals to 2. Type of the system is equals to 1 and order of the system is equal to 2. So it doesn't matter whether you do closed loop or open loop, order of the system it can be calculated. But for the type of the system, it is always to convert into the open loop, then only you will get the idea about the type of the system. Because the thing is, why this type of the system is important, you know, for understanding the steady state error concepts also. Okay, I hope it is clear. Now let us see one more question. Okay, now see this question. Type of an open loop system depends on. Type of open loop system depends on let us say the general representation of a transfer function is k into 1 plus s tau 1 into 1 plus s tau 2 and so on whole divided by s raised to the power of n into 1 plus s tau a into 1 plus s tau b and so on. So this is general representation of an open loop transfer function of a system. So now you see he's asking the type of the system. It is always depends on how many poles at origin. Always the type of the system defines number of poles at origin. As per the question, if you see the number of its poles, difference between the number of poles and zeros, number of its real poles, number of poles it has at the origin. So therefore, which option is correct? This is the option is correct. Type of the system only we are talking about. If suppose if it is order of the system, we are going to either you can use this open loop system or you can do the closed loop system, doesn't matter. Along with this poles at origin, you have to check the other poles also. So these poles are what? Real poles. These poles are what? Real poles. These are poles at origin. Okay, so that's the difference between these two. So generally what we will commit a mistake means number of its poles. There is a possibility of this. Number of its real poles only. Real poles means comes this. But this is not defines your type of the system. Number of poles at origin will decide the type of the system. If n is equals to 0, n will start from 0. Okay, n is equals to 0, n is equals to 1 and so on. If n is equals to 0, which is called type 0 system. Type 0 system. If n is equals to 1, it is called type 1 system. Clear enough? Yes. So this is how we have to identify the how many poles at origin. How many poles at origin? Yes, it will decide the type of the system. Okay, na? Now let us see another question. So the second order overall transfer function is given by 4 upon s square plus 2s plus 4. Okay. So what is they're asking? They're asking the resonant frequency. Omega n they are asking. How to calculate the omega n? Compare this equation with our standard second order system equation. What is that? Omega n square by s square plus 2 zeta omega ns omega n square. If we compare this transfer function with respect to this standard representation of the second order system, omega n refers what? Omega n square is equals to 4 and omega n is equals to plus or minus 2. But frequency will never be negative. So therefore, it is always plus 2 radians per second only. Okay. So what is that value? 2 radians per second. Got it? So frequency will never be negative. That is what is 2 radians per second. Now let us see another question. So if you see the question, what is that? The second order system, and they have given it is a closed loop transfer function also. They have mentioned it is a closed loop transfer function. And what is they are asking? Settling time. Settling time for 2% band. Settling time for 2% band in seconds. So what exactly the settling time for this? The settling time for second order system TS is equals to 2% band. That means for 2% tolerance, what is the settling time? Which is nothing but 4 time constants. And for 5% tolerance, the time constant is equals to 3 time constants. Settling time is 3 time constants, where tau is called damping coefficient and we can call it as 1 by zeta omega n. So first we need to find out the omega n from this. From the standard by comparing the standard representation of second order system, what is the omega n square you got as per this 9? From this, what is omega n is equal to 3 only, because it cannot be negative, right? Now what about zeta? So 2 zeta omega n is equals to how much? 4. Then what is zeta? 2 go this side, this will be 2 by 3. Then what about this settling time for 2% tolerance? Ts is equal to 4 into 1 upon, yes, zeta omega n. What is zeta? 2 by 3. What is omega n? Which is 3. So 3 gets cancelled, and always the answer is 2 seconds. Answer is 2 seconds. So here it involves multi-concept. First concept is what? You have to identify the settling time. First you have to identify the settling time relation for the 2% band, which is nothing but 4 time constant. But we should know what exactly the time constant of. It is also called damping coefficient, which is nothing but 1 by zeta omega n. So that means here total 1, this is 1 to 2 unknowns are there, and also this is we have to calculate. So zeta omega n from the transfer function standard value we found, which is omega n is equal to 3, and from this we have calculated the zeta and substitute, and we got finally. Okay now? So the answer is A. Now let us see one more question. Now let us see this question. It is like a match the following, and they're asking like choose the correct answer with respect to the nature of the damping and the characteristic equation they have given. So if you see, the characteristic equation for A is what? S square plus 15s plus 56.25. Correct only na? 56.25. So we have to calculate first omega n. What is omega n? Root of 56.25. So 56.25 root value is equal to 7.5. So now what is the 2 zeta omega n value? 15. So zeta will be 15 divided by 2 into 7.5, which is nothing but how much? 1. So when zeta is equals to 1, then we will call it as what? It is called critical damping. It is called critical damp. So therefore can I say A is refers to 3. A is refers to 3. Now let us see B also. What is B? S square plus 5s plus 6. What is omega n? Root 6. What is root 6? It is approximately equals to 2.44. What about 2 zeta omega n? 2 zeta omega n equals to 5. From this, zeta is equals to 5 upon 2 into 2.44. So its value is definitely denominator less than 1, I can say. So something value which is less than, less than 1, less than 5. So 5 by less than 5 will be always greater than 1. 5 by less than 5 is always greater than 1. If it is greater than 1, we can say that it is what? Over damped. This is called over damped. This is called over damped. So which is that? This one is over damped. If you observe very carefully, C is very easy. C is equals to what? From this transfer function only we can say S square plus 20.5. Here you can calculate omega n is equals to, let us say, root of 20. You can say 25. But where is 2 zeta omega n? S coefficient is 0 na, no coefficient of S is there. So what is that value? Obviously zeta straight away is going to be 0 since omega n is not 0 na. So therefore this is going to be zeta equals to 0 means undamped. We know that undamped means what? Oscillations will be there continuously. And what else left? Obviously underdamped, this one only. Okay. So it means 42.25 ka omega n, you see no problem. D equals to what? S square plus 4.5s plus 42.25. So what is omega n from this? Root of 42.25, which is nothing but what? 6.5. Right now 6.5. Now you tell me 2 zeta omega n is equals to what? 4.5. From this, what is zeta? 4.5 divided by 2 into 6.5. So definitely denominator value is 13. So obviously this ratio will be always less than 1, which is nothing but like this. So less than 1 means obviously it is underdamped system. Okay? So therefore, what is the order? A refers critically damped 3, B refers overdamped 4. So 3, 4, 2 options are there, and this is undamped. C is equals to 1. So C is equal to 1. This is the option correct. Got it? So a unity feedback control system has forward path transfer function is equals to 42.25 by S into S plus 6.5. The unit step response of the system starting from rest will have the maximum value at time equal to. So they are asking indirectly peak time. So how to deal with that peak time? First of all, this is open loop transfer function. G of S is equals to 42.25 divided by S square plus 6.5s. Correct? Its closed loop transfer function. Its closed loop transfer function is 42.25 divided by S square plus 6.5s plus 42.25. Okay, 42.25. So from this, can I calculate omega n? What is omega n? Root of 42.25, which is nothing but 6.5. It is 6.5 only. Now what is zeta value? What is zeta value? Can I say 6.5 divided by 2 into 6.5, which is nothing but what? 0.5. Zeta value you got 0.5. Now what they are asking? Peak time. Yes or no? Peak time. Peak time Tp is equals to pi by omega d. Right. What is omega d? Pi by omega n into root over 1 minus zeta square. So we have every value now. Pi by, what is omega n value? You got 6.5 root of 0.5 square. Right? So from this you simplify it and you will get it. Okay na? How much we are getting? So this is indirect way also you can check. Pi by 6.5. You know, this is 0.5, 1 minus 0.5 square, and it will be what? 0.75. And if you multiply, this is 0.75, which is nothing but 75 by 100. Obviously this value will be like somewhat